A plank with a box on it, one end of it gradually rises about the other edge as the angle of inclination with the horizontal reaches 30 degree. Okay, this angle that is equal to 30 degree, a plank is placed here. The box starts to slip and slides 4 meters down the plank in 4 seconds. Okay. So this plank is placed here, and when it is angle is increased up to 30 degree, this box will moving downwards in 4 meters in 4 seconds. The coefficient of the static and kinetic friction between the box and the plank will be respectively we need to find here. Yeah, the friction we need to find here. We know that the coefficient of static friction is calculated as, that is mu s is equal to tan of 30 degree. Then this value is equal to 0.577. Then approximately we can take this one as 0.6 mu s. For the coefficient of kinetic friction, we start with the equation of motion. That is, ma is equal to mg sine 30, that is sine 30 degree. They are given the angle is theta, that is nothing but 30 degree, minus f, where f represents the friction here. Then we can rearranging this one as ma is equal to mg sine 30 degree minus of mu times k into mg cos 30 degree. Then we know that displacement, that is s is equal to the equation ut plus half into at square. By substituting the values, that is s is equal to 4, u is equal to 0, that is initial velocity, time is equal to 4 plus half into a need to find, and time is equal to 4 square. Then 4 is equal to 0 plus half into 16 times a. Then we can get cancel this one 8 times. Then a is equal to 4 by 8, which is nothing but 1 by 2 or 0.5 meters per second square. Then now substituting a 0.5 in the above equation, we get the answer, that is 0.5 is equal to 10 into 1 by 2 times mu k into 10 into under root 3 divided by 2. Then solving the value here, then mu k is equal to, we can get it as 4.5 divided by 5 root 3. We'll get the value 0.5. Then mu k is equal to 0.5 and mu s is equal to 0.6. Then we can say 0.6 and 0.5. We can see in the option C. Option C is the right answer.